Welcome to Aksharashala. This video is last video for this particular unit multivibrators. In this session, we are going to cover various triggering methods, triggering the bistable multivibrator, and triggering the monostable multivibrator. Only these two multivibrators requires triggering. A stable multivibrator doesn't require any external triggering. So then how to trigger these two multivibrators to induce a change in its stable state? Let us discuss now. Triggering the bistable multivibrator. We know that bistable multivibrator has got two stable states and that it can remain in any one of the states indefinitely. The process of applying an external signal to induce a transition from one state to the other is called triggering. The triggering signal which is usually employed is either a pulse of short duration or step voltage. You can apply a pulse or a step. Methods of triggering. There are two methods of triggering. One is unsymmetrical triggering. Second one is symmetrical triggering. Unsymmetrical triggering is one which is in which the triggering signal is effective in inducing a transition in only one direction. In this, second triggering signal from a separate source must be introduced in a different manner to achieve reverse transition. Symmetrical triggering is one in which each successive triggering signal induces a transition regardless of the state in which the bistable multivibrator happens to be. That is, unsymmetrical triggering requires two separate sources, whereas symmetrical triggering requires only one external source for symmetrical triggering. Unsymmetrical triggering finds extensive applications in logic circuitry for storing the information or coding the information, and it can be used as a generator of a gate pulse. Whose width equals to the interval between these two triggers. Symmetrical triggering is used in binary counting circuits and other applications. The triggering signal may be applied at the output of a stage or at the input of the transistor or output of a transistor. In transistor circuits, the triggering signal may be applied at the collector of a transistor at the base of the transistor. You can apply either at collector or at base of the transistor. An excellent method for triggering a bistable multivibrator is unsymmetrical triggering. In unsymmetrical triggering, the leading edge of a pulse is to apply the pulse from a high impedance source to the output of the non-conducting device. That means a negative pulse is leading edge of a pulse means a negative pulse is applied at the output of the non-conducting state. At the output of the non-conducting state. That means at the output of and at the collector point of off transistor, you have to apply a negative pulse. For PNP transistors, a positive pulse needs to be applied. For NPN transistor, you can apply a negative pulse at the collector of off transistor. The triggering signal may be applied through a resistor and a capacitor, or in another method through a unilateral device such as diode. This figure represents the method of triggering unsymmetrically through a resistor and capacitor. If PNP transistors are employed, the polarity of the triggering signal should be reversed. Suppose if you apply negative pulse here, for PNP transistor, positive pulse is required. That is the only basic difference when circuit is implemented using PNP transistors. triggering unsymmetrically through a unilateral device. Unilateral device means diodes. This figure shows the unsymmetrical triggering through a unilateral device when the signals are applied at the, now here triggering signal is applied at the collector of on transistor. Here triggering signal is applied at the collector of off transistor. Suppose in one stable state Q1 is on, Q2 is off. Let us consider this particular stable state. When Q1 is on, the diode, so what happens to potential at this point? Potential at this point is VC sat only. But here cathode of diode is directly connected to VCC. Cathode is more negative than more positive than anode. Anode is at only VC sat, no? So cathode is more positive than anode. So diode D gets reverse biased. So it doesn't transmit any signal to the base of the off transistor, right? So the diode at the collector of Q1 is back biased, reverse biased by the drop across RC, because its anode is at VCE and cathode is at VCC. So this cathode is at VCC but anode is at VC sat. So anode voltage is less than cathode voltage. So hence this diode gets reverse biased. So the diode, so what happens when this diode is reverse biased? It will not transmit a positive pulse, even if you apply negative pulse, that is also cannot be transmitted unless it has high amplitude than this voltage drop across voltage drop, which, so anyway it cannot affect the state of transistor Q2. Even if you apply positive pulse or negative pulse, it cannot affect the state of transistor Q2. So no change of state can take place by the amplification of a pulse at the collector of Q1 when Q1 is on. When Q2 is off, both anode, so here you can see both anode also connected to VCC, here cathode also connected to VCC. Why? Because here Q2 is off, no? Off means potential at this point also VCC only. So here for this diode, both anode and cathode both are connected to VCC only. So the drop across diode is almost zero. Anode voltage is equivalent to cathode voltage. So no drop across diode. So the diode will still fail to transmit. Suppose if you apply a positive going pulse at this point, what happens? Cathode voltage increases, so it cannot transmit. Suppose if you apply negative pulse at this point, what happens? Cathode voltage less than anode voltage, then this diode starts conducting. It transmits the negative pulse to the base of an transistor, which brings the transistor Q1 into off state. Initially it is in on state, no? So if you apply a negative pulse at this point, it will be transmitted by the diode D to the base of on transistor, which brings the on transistor into off state, which result in a change of state. Eventually, due to regenerative feedback, so automatically Q2 enters into on state. So when Q1 is on, Q2 is off, only negative pulse is applied at this R point. R can change the state. The only negative pulse is applied at point R, which will change the state of the bistable multivibrator. This figure represents unsymmetrical triggering through a diode. Unsymmetrical triggering through a diode when triggering pulses are applied at the bases of, so triggering pulses is applied at the bases of the transistors. Here a negative pulse is applied through, here negative pulse is applied through diode D at the base of the on transistor. At the base of the on transistor. Here R is, here R is there, no? So R is returned to the ground, rather than here initially it is connected to VCC in previous diagram. Here R is returned to ground rather than the supply voltage. Here R is returned to the ground like this. Through this capacitor and resistor it is connected to ground. Earlier this point is connected to VCC. If the trigger amplitude available is small, it may be necessary to amplify the signal before applying it to the bistable multivibrator. Triggering symmetrically through a unilateral device. Let us see, this figure represents an arrangement for symmetrical triggering through diodes. Symmetrical triggering to diodes at the collector. So the diodes are connected at the collectors of transistors. At the collectors of transistors. Q2 is on, Q1 is off in one of the stable states. The collector of Q2, so this is on, no? So potential at this point is VC sat only. VCE sat. So the collector of Q2 is at VC sat. Here VC sat will be available. Only VC sat will be available at this point. Whereas Q2 is off, no? So collector of this point, collector of transistor will be at VCC. Why? Because no collector current flows in this circuit. So entire VCC will be available at this point. So then what happens? This at this point VCC is there. VCC is there, so diode D1 gets forward biased. But this point is only VC is at, and at this point VCC is there. So why? Because this is forward biased. So at this point VCC is there, same VCC is available at this point also. So collector of D2, cathode of D2 is at VCC, but anode of D2 is at VC sat. VC sat is less than VCC, so diode D2 gets reverse biased. So D2 is reverse biased by VCC, and D1 is at, so is both anode and cathode both are at VCC, no? So D1 is at zero bias. So hence a negative input signal. So if you apply a negative input signal at this point, it will be transmitted through D1 to the collector of, so this negative pulse will travel like this. Will travel like this to this point. This point means collector of transistor Q1. So from this point it will be transmitted through the base of on transistor through the combination of R1C1, and it connects the output of Q1 to the base of transistor Q2. This negative pulse at the base of transistor Q2, this negative pulse is transmitted to the base of transistor Q2, which brings the on transistor into off state. So thus causes the transition in the bistable multivibrator. After the transition is completed, D1 will be reverse biased and D2 will be at zero bias. So why? Because this enters into off state, no? So D2 will be at zero bias. This will be forward biased and this will be at reverse biased. So after transition, so the next negative pulse will pass through D2 instead of D1. Hence these diodes are called steering diodes. So these two diodes acting like a steering diodes. These two diodes are playing crucial role in inducing the transfer of state in the bistable multivibrator. That's why these diodes are called steering diodes. The bistable multivibrator will change state at each successive negative pulse. At each successive negative pulse or step. You can apply pulse, negative step, or pulse. You can use a pulse or step, but will not respond to the triggers of opposite polarity. The diode D3, here you can see diode D3 in earlier diagram. In place of D3 we used one resistor. So here diode D3 serves the purpose of resistor in unsymmetrical triggering. If PNP transistors are used, then the diodes must be reversed and positive triggering signal would be required. This figure represents the arrangement of symmetrical triggering through the diodes at the bases of transistors. Here triggering signal is applied at the bases of the transistors. At the basis of the transistors. Triggering may also be done symmetrically without the use of the auxiliary diodes, additional diodes. The presence of commutating capacitors. So already we discussed about commutating capacitors. So presence of this commutating capacitors facilitates this. But for this commutating capacitor must be large. The large values of commutating capacitors lengthen the settling time of the binary. This is also a problem. Therefore, this method of triggering without auxiliary steering diodes is not employed where the shortest possible resolution time is required. If we increase commutating capacitors value, what happens? It increases the resolution time. Suppose if your requirement is shortest resolution time means increasing the frequency at which binary should respond. If it increases, what happens? Speed decreases. Suppose if you want more speed, you should not employ this type of triggering. This figure represents the arrangement of triggering a self-biased bistable multivibrator without steering diodes. Here you can see no diode is used here. Here a positive step. Here a positive step is applied at the common emitters of the flip-flop. Emitters are connected together and connected to ground through a common emitter resistance. Symmetrical triggering of this is self-biased bistable multivibrator. In this way, triggering is applied to both types of bistable multivibrators. Now let us see triggering on the monostable multivibrator. A monostable multivibrator needs to be triggered by a suitable signal in order to switch it from the stable state to the quasi-stable state. However, after remaining in the quasi-stable state for a time t equivalent to 0.693 Rc, it automatically switches back to the original stable state without any triggering signal applied. Thus, unlike a bistable multivibrator, monostable multivibrator requires only one triggering signal. Hence, only unsymmetrical triggering techniques are adapted for monostable multivibrators. Generally speaking, all the triggering methods which are applicable to the bistable multivibrator are also applicable to the monostable multivibrator. The collector coupled monostable multivibrator is normally triggered by applying a negative pulse at the collector of off transistor. At the collector of off transistor, a negative pulse is applied for NPN transistors. So this negative pulse is applied through resistor and capacitor. So this acts as a capacitor followed by resistor, acts as a high pass filter. High pass filter acts as a differentiator for small time constants. So if you apply negative pulse, output of this differentiator will be positive and a continuous series of positive and negative spikes. These spikes will be transmitted to the base of on transistor. In this way, triggering is applied for a collector coupled monostable multivibrator to induce a change in its stable state. The positive spike, so suppose if you get a positive spike at this point, what happens? Cathode is more negative than anode. And negative spike is, so suppose if you apply negative spike, so it is it gets forward bias. This negative spike is transmitted through this capacitor to the base of on transistor, which makes the transistor on transistor into off transistor, which brings the on transistor into into cutoff state. So Q2 goes to off state and eventually Q1 goes into on state. So this method has two advantages. One is, as we know, the multivibrator is more sensitive to a pulse of such a polarity, which brings the on device to the off state. The second is at the instant of the transition, the collector of Q1, this is the collector of Q1 drops. Q1 drops, the diode no longer conducts, and the multivibrator doesn't respond to the triggering signal till the quasi-stable state is completed. This is one disadvantage. Disadvantage, you can say it as a advantage or disadvantage, but during this time it won't respond. The emitter coupled monostable multivibrator may be triggered by applying a positive pulse of sufficient amplitude at the base of Q1. At the base of Q1, triggering signal is applied to bring the off transistor into on transistor. This method is applied for inducing a transition in its stable state of emitter coupled monostable multivibrator. For any queries, please contact aksharashala@gmail.com. For further updates, please subscribe to Aksharashala. Thank you.